Welcome to my 7th section, How to Deploy Keras Models into Production. In this section, we're going to take a look at options for deploying models into production. We'll explore creating a model for deployment. We will dive deeper into creating a Flask app for production use of Keras model predictions. And finally, explore an example of leveraging the cloud to actually deploy a model into production. In this first video, let's tee up some examples and options around deploying Keras models. It is important for us to explore this as it's a key aspect to machine learning. After you've created your Keras models, you'll want to employ a system that allows you to take those models forward and use them in real-world applications. You'll also need to think about things like how do you update the model if new data becomes available. So let's explore some ways to deploy your Keras models today. This is not an exhaustive list, but highlights some key interesting ones. First, there is TensorFlow serving, which is a layer for TensorFlow. You can deploy it natively in the cloud using one of the big cloud providers. You could package up your model in a Flask app as a container. This allows you to deploy it anywhere that containers can run. And then interestingly, you could also deploy your model client-side using Keras.js. TensorFlow serving is a flexible, high-performance serving system for models. It's designed for production environments and is pretty simple to get going with. It supports Keras models today. On the left here is a snippet of code that shows how to start the server. You simply call TensorFlow model server, you give it a port that you want it to listen on, the name of your model, and the base path for your model directory. At that point, TensorFlow serving will pick up your Keras model and expose it in a way that you can make HTTP request posts to that. As you can see here on the right, there is some sample code that is simply pushing some data into that to get a prediction back. Pretty simple to use. Another interesting option for deploying your Keras models is using a cloud provider. The three big ones are Microsoft Azure, Amazon's AWS, and Google's cloud platform. Microsoft Azure supports various options for deploying your Keras models. One of these includes the Azure Machine Learning Service. This service is pretty simple to use and pretty powerful. It wraps the whole end-to-end machine learning lifecycle for you, from creation, experimentation, training, through to deployment, in some very simple commands. On top of that, you can also take your cloud models and package them up to deploy them at the edge. This would be useful in scenarios where you were disconnected or wanted to do things in real time. Of course, within Azure, you can certainly take your Keras models and deploy them to a virtual machine. You can also package them up as containers yourself and run them on Azure Kubernetes clusters. Similarly with AWS, there are options to run your Keras models, obviously within a virtual machine or a virtual machine backed with a GPU. AWS have something called SageMaker, which allows wrapping up your Keras models and deploying them in a simple fashion. On top of that, you can also use containers within the AWS ecosystem in various guises, one being Fargate, for example. Again, with Google Cloud Platform, there are similar options. Google has its AI platform, which allows and makes it easy to deploy cloud models. On top of that, you could take your Flask application that's exposed to your prediction engine and run that on the App Engine. And of course, you can run containers in Google, and as well as virtual machines and GPU-based virtual machines. As you can see, across these cloud providers, there are a lot of different options to explore. When we talk about containers for our Keras models, what we're really talking about is creating a Flask app and then creating a container off of that. If you're not familiar with containers, think about them as a way of packaging up an application and all of its dependencies and then giving it to someone else to run without them having to install anything. The container contains all of the information it needs to run your app successfully. You essentially, for a Flask app, define the starting point, which could be the Python 3.6 default image, copy your application over to it, copy the requirements.txt, which contains all the Python packages it needs, and at that point, build your Docker image. Keras.js is interesting. This allows you to run your Keras models client-side, pushing down the power for processing predictions to your clients. This could have some interesting use cases in applications such as real-time scenarios or in scenarios where you don't want to be sending data off to a centralized processing facility such as the cloud. Here's a snippet of code showing how it might work using Keras.js.